Hello class, and welcome to Chapter 3, which is about linear functions. Our first lesson, 3.1, is going to be about relations and functions. By the end of today's lesson, you will be able to identify domain and ranges and think about reasonable values for those, identify functions, and identify constraints on the domain. So the first thing we're going to talk about is a relation is a set of ordered pairs. So any list of ordered pairs that you could put onto a graph in any order, doesn't matter to the numbers, that's a relation. A function is a specific type of relation where each input, so each x value, has exactly one output, the y values. So everything that we put in is going to have one specific answer that comes out. Those inputs we can also call the domain. You might also hear them referred to as the independent variable. Those are the things that you're choosing, the things that you are putting in or the things that are controlling the scenario. The range or the outputs or the dependent variables are the things that are happening because of the choices that are made. So looking down here at these four different sets of relations, this first one, it is a relation. It's just a set of ordered pairs. Second one's a relation. The third one's a relation. The fourth one's a relation. So they're all relations because they're all sets of ordered pairs. Now looking more specifically at a function, we need to make sure that each x has a y. So 1 goes with 2, 9 goes with 8, 7 goes with 6. Each x has a y, so this is a function. Looking at the second one, we've got 1 goes with 2, 9 goes with 8, 7 goes with 6, and 1 goes with 2. 1 and 2 show up twice, but it's the exact same thing, so it is still a function. For the third one, 1 goes with 2, 5 goes with 8, 7 goes with 6, and 5 goes with 2. Each x has its own answer, so this is also a function. It is okay for two different x's to have the same y value. Again, it is okay for two different x's to have the same y value. This last one, 1 goes with 2, 9 goes with 8, 7 goes with 6, and 1 goes with 5. This is not a function. The reason being is that our x value of 1 is getting two different answers. So it is not having each input going to one output. That input is going to two different outputs. So that is not okay. There are two different types of domains. So there are two different types of inputs. The first is called a continuous domain. That's where the inputs are all the real numbers. So fractions, decimals, positive, negatives, square roots, all of that kind of stuff are included in continuous domains. If you have a continuous domain, the graph is going to be connected. So it's going to be a line, a curve, something to connect those separate points. Things that would be examples of continuous domain: amounts of time. You can have half hours, you can have whole hours, you can have quarters of an hour. Distance, same thing. You could have 6.7 miles or 1.84 kilometers or 2 3/4 miles. Money, because we have dollars and cents. So those are all continuous. A discrete domain is where the inputs are only whole numbers or integers. So they're either staying positive or negative, and then the numbers on the number line. So no fractions, no decimals. These are graphed as a series of data points. They are not connected. So for example, something that might be a discrete domain is people. You can get an answer for one person or two people or three people, but you can't get an answer for 2.5 people. That's not a valid input. Another example of that would be cars. You're not going to have 1.75 cars. or water bottles. You're not going to have 3 5/8 water bottles. So things that have to be whole are going to be a discrete domain, and those points would not be connected on a graph. The last piece of vocab here is what we call a mapping. This is a visual illustration of the domain and range, and it makes it very clear whether something is a function or not. So when you're doing a mapping, your first job is to look at all of the members of the domain, so all of the x values. And you're going to put those x values into numerical order from least to greatest. So -2, -1, 1, 4, and 5. Then over on the other side, under the range heading, we're going to have all of the members of our range. Again, starting with the smallest. So we got -2. Even though -2 is listed twice, we're only going to list it once. 2, and then 5. Again, 5 is listed twice, but we're only going to list it once. What the map does is it gives us visual. So 1, the output is 2. 4, the output is 5. 5, the output is -2, -1. The output is 5, and -2, the output is -2. Now, the reason I said that this is a really easy way to determine if a function or if a relation is a function is by looking at the members of the domain. If there's only one arrow coming out of each number, then it is a function. If, for example, there had been another arrow that went from -2 to 2, because there was another point, -2, 2, then it would no longer be a function because there are 2 arrows coming out of one number. So if each number in the domain only has one arrow coming out of it, it's a function. If each if each number in the domain has more than one coming out of it, then it's not going to be a function. The other thing that mapping shows us really well is what we call one-to-one. So a function is one-to-one if each member of the domain goes to only one member of the range. So this is not one-to-one. In order to be one-to-one, the arrow needs to go, each number in the domain can only have one arrow going out, and each element in the range can only have one arrow coming in. Since there's 2 arrows coming in here on the 5, it is a function, but it is not a one-to-one function. So we're going to go ahead and identify some functions here. Looking at this first one, our list of points, we got 1, 2, 5, 6, 7, -1, and 8, 0. We've got each element of the domain is going to one element of the range. This is a function, and it is also one-to-one. So you would say that it is a function, and it is also a one-to-one function. Coming in and looking at this map over here, we've got each number in the domain only has one arrow coming out, so it is a function. On the range side, there are 2 arrows going into 17 and 2 arrows going into 10, so it is not one-to-one. And then the last one, the graph, this is one more test that we can use to determine if something is a function. If you take a vertical line, a pencil, a pen, anything that you can put straight vertically up and down, and you drag it over the top of your function, as long as the vertical line is only hitting your graph at one point during this whole time, it is a function. So this particular graph right here is a function that we can, and then we have to determine if it is one-to-one. And in order to determine if it is one-to-one, we're going to take and we're going to look at a horizontal line. So does each Does the graph only hit horizontal lines once? Since it only hits the horizontal lines once, this is a one-to-one function. Go ahead and determine if these two are functions on your own. So now that we look at A, we know that it is not a function because there are 2 arrows coming out of 3. We look at part B, and it is a function. Now I want you to determine, is part B one-to-one or not one-to-one? Part B is a one-to-one function because each element of the domain has exactly one range value. We also want to look at being able to just list domain and range. So this is very similar to the mapping, but instead of drawing them with arrows, you're just going to list them out as domain. I use this squiggle when you are typing into Edpuzzle or into Pearson or any of those things. If you hold your shift and then the bracket key next to the letter P on your keyboard, and you hit that, you're going to get that squiggle bracket. That's the actual bracket. I'm not very good at drawing that, so I just use a squiggle mark. But we've got our domain. Again, we're going to list our x values then from least, so -3, -1, 1, 3, and to greatest, which is 4. And then for our range, again, we want to look at our values, starting with the smallest one, which is -5. Then we have -2 that occurs twice, but we're only going to list it once. And then we've got 1 and 3. So go ahead and list the domain and range for this one on your own. You've got your domain -5, 2, 3, 4, 6, and your range of -2, 0, 1, 3, 4. Now we're going to talk about, now that we can identify the domain and range, talking about reasonable values for this. So, for example, a hose fills a 10,000-gallon swimming pool at a rate of 10 gallons per minute. Is the situation continuous or discrete? So the first thing we're going to have to figure out is what is the domain and what is the range. So we're looking at what is changing and what is happening as a result of that change. So in this case, what is changing, our domain, is going to be the amount of time. So we're looking at over the course of time, the pool is going to get more and more full. It's not that the pool filling up makes time pass, it's that time passing makes the pool fill. So you want to always first think about what is your domain and what is your range. Next, you're going to actually want to determine what values make sense for that. So this is the reasonable part. So for our domain, we're talking about filling a swimming pool. So the lowest we can get is the start. So 0 minutes have passed. And then we're going to go until the pool is full. How long is it going to be until the pool is full? That's when we need to use our information. We've got 10,000 gallons and 10 gallons per minute. So in order to figure out the amount of time, we're going to take our full pool, divide it by that amount of time, and that's going to give us 1,000. So our domain then is going to be 0 to 1,000. And we want to be even more specific about that. Thinking about the types of numbers. So can you have decimals? Can you not? So this is going to be 0 to 1,000 real numbers. It's okay to have decimals. It's okay to have fractions. It's okay to have 3.14, etc., minutes. So you can have any amount of time. Now looking at our range, we've got the pool starts at empty, so 0, until it's full, which is going to be 10,000 gallons. And again, that's going to be real numbers. So we think about the kind of values that we can have for the amount of water in the pool. Those can include decimals and other numbers, so we have the real numbers. Last thing it asked was, is it continuous or discrete? When we determine that, we look at our domain, We've got real numbers, so decimals and fractions are included, so this is continuous. For this next example, we have a scenario that says a restaurant needs to order chairs for its tables. One table can accommodate 4 chairs. The first thing I want you to do is to determine the label for the domain and the label for the range. So our label for the domain is tables. Our label for the range is chairs. Now I want you to figure out the numerical values that would be associated with the domain and the numerical values associated with the range. In this case, we have our domain is going to be whole numbers. You can have a whole number of tables, 0, 1, 2, 17, 27, 54. All of those different numbers could be the amount of tables that they have. The range is whole numbers, but it's going to be in multiples of 4. So 1 table has 4 chairs, 2 tables has 8 chairs, 10 tables has 40 chairs. So we're not going to have the numbers in the middle. So this one was a little bit tricky, but you want to make sure you are only talking about the specific outputs that you could have. So 4, 8, 12, etc. Last thing I want you to do is determine if the situation is continuous or discrete. Because your domain is whole numbers, this is going to be a discrete scenario. Last thing we're going to do is talk about specific constraints that might happen with the domain. So for the first example, Margaret has a monthly close budget of $50. She maps the amount of money she spends each month to the number of items she can buy. What are the constraints on the domain? So we're looking for, first we've got to figure out what the domain and the range are. So in this case, what is the thing that is causing things to happen? That's going to be the money. How much money she spends is going to result in the clothes that she buys, or the items of clothes that she can buy. So we're looking for the limits around the money, and for this particular one, our constraint is going to be between 0 and $50. Those would be the reasonable values that we could put in for x. You could also write this out as 0 is less than or equal to x, which is less than or equal to 50. So writing it out in that inequality format. Looking at the second one, a company charges 75 cents per pound for a shipping fee when it mails packages. What are the constraints on the domain? Again, we need to identify the domain and the range. The thing that is determining the scenario here is going to be the weight, or the pounds, and what it's determining is the cost. So how much it weighs determines how much it costs. In this case, when you are thinking about the weight of packages, there might not initially seem like there is a constraint, but there is. In this case, your package is going to be weighing more than 0 pounds. It can't be equal to 0 pounds, otherwise the package wouldn't exist. Packages can't be weightless, and they can't have negative weight. So our constraint is that we have to plug in something greater than 0. For this last example, John runs between 3 and 15 miles. Each day he tracks his miles and how many minutes it took him to complete his run. What is the constraint on the domain? In this case, the domain is going to be the miles and the range is going to be his time. So our constraint is between 3 and 15. Or again, if you write it out in the inequality, 3 is less than or equal to x, which is less than or equal to 15. If you have questions about this or anything else from the lesson, please let me know when you get to class.